What's up guys, Derek, moreplacerenades.com. Today, as you see by the title, I anticipate this video won't do well. So that's partially why the title is the way it is, but it's also a topic I find really interesting, but it's hard to, spin it in a way that's going to get scooped up by the good old algorithm. So we shall see what happens. But basically, I've followed research in the longevity, anti-aging space for a while now, as it is something that greatly interests me, and it has a lot of crossover with the kind of like biohacking stuff that I also research. It all sort of like blends in with the whole like self-improvement, red pill kind of shit. Like there's all this intertwined with like biohackers, self-improvement dudes, longevity research, etc., all trying to be like the most maxed out thing that you can possibly be, essentially. And something that was notable that came out recently was David Sinclair tweeted the other day, "What a journey, what a team. So grateful to be involved in this discovery." And basically what they published was an article was published, it was received July 31st, 2019. It was accepted the 22nd of October, and it was finally published online handful of days ago, and it's about his most recent research on aging. And this is like one of the most, forward-thinking longevity researchers in the space, or anti-aging. He's been featured on Rogan, he's been featured on many different podcasts, and he is like I don't know if he's like the world's most renowned expert in anti-aging or like whatever, but anyways, he is a biologist, David Andrew Sinclair, Australian biologist who is a professor of genetics and co-director of the Paul F. Glenn Center for the Biology of Aging at Harvard Medical School. And this has been his like life's work at this point. Well, his passion, and in the past, however many decades, his life's work. And he published a book recently called Lifespan, Why We Age. And I thought it was a good read. So I'd recommend, if you're interested in this stuff whatsoever, to get a more elaborate deep dive into sort of his, theories and whatnot, and sort of the breakdown of what really happens to the body and how things go awry, things go awry at a cellular level, and how you can sort of mitigate some of that damage potentially. It's a very interesting read for sure, and I've been following his work very closely. And I actually did a video last year in 2019 called David Sinclair's Supplement Stack for Anti-Aging, What He Takes and Why. And basically I broke down exactly what this guy claims he takes for anti-aging, at least at the time last year. And if I recall correctly, it was like a combination of nicotinamide mononucleotide, resveratrol, metformin, and I think he was on a statin too, and like some other stuff. But anyway, so I like broke down his supplement regimen in that video, and it was like pretty insightful for figuring out what a guy who is at the forefront of this industry, to see what he deems like worthwhile in terms of molecules to implement into your, he's not suggesting you do, but what he does himself for preserving his lifespan for as long as possible. Anyways, the article that was published is a big deal, because it is essentially breaks down how they were able to reprogram a mouse to recover epigenetic information, restore vision. So he sort of, I think, described this on Rogan closer to the end of the podcast, how basically here, I'll just read the abstract and you'll get a better idea instead of me trying to summarize it for him. Aging is a degenerative process that leads to tissue dysfunction and death. A proposed cause of aging is the accumulation of epigenetic noise that disrupts gene expression patterns, leading to decreases in tissue function and regenerative capacity. Changes to DNA methylation patterns over time form the basis of aging clocks, but whether older individuals retain the information needed to restore these patterns, and if so, whether this could improve tissue function, is not known. Over time, the central nervous system loses function and regenerative capacity. Using the eye as a model, central nervous system tissue, here we show that ectopic expression of OCT4, also known as POU5F1 and SOX2 and KLF4 genes, OSK in mouse retinal ganglion cells restores youthful DNA methylation patterns, and transcriptomes promotes axon regeneration after injury and reverses vision loss in a mouse model of glaucoma in aged mice, the beneficial effects of OSK-induced reprogramming in axon regeneration and vision required the DNA demethylases TET1, and TET2. These data indicate that mammalian tissues retain a record of youthful epigenetic information encoded in part by DNA methylation that can be accessed to improve tissue function and promote regeneration in vivo. So as far as I know, like they're actually like proving this at this point and able to like literally reverse blindness in a mouse. So like think of when you get older, what goes wrong? You start to, have weathered, wrinkled skin, your skin quality goes to shit, hair falls out, which are organs, by the way. All of a sudden you might need glasses, whereas you didn't however many years prior. Bone degeneration, muscle loss, like all of these degenerative processes that are essentially dictated by your body's inability to sort of fulfill physiologic functions properly because of this supposed epigenetic noise. So basically the proposal is like obviously just the aging process in itself, just being alive and expending energy and literally like supporting your organ function is a process that is going to age you, because just literally being alive is a process in itself. But then above and beyond that, lack of sleep, poor diet practices, poor micronutrient intake, no exercise, no hormetic stressors, you're not trying to impose any reason upon your body to kind of adapt and, recover. No utilization of autophagy by having, like intermittent fasting, whatever it is that, maybe redlining your body to an aging process quicker. The sort of proposed theory that, if I recall correctly, is basically you get like, your body is like a disc, like a CD, and the more scratches you accumulate on it, the harder it becomes to read. And it's not necessarily that you don't have the right like infrastructure to have the proper gene expression patterns. Rather, it is all of this noise, like the scratches on the disc, that are preventing you from being able to carry out those functions correctly now. And your body is like overwhelmed, trying to like, none of the fucking shit works anymore, basically, because of all this epigenetic noise that has accumulated over the years. And it has a compounding effect that makes things worse and worse. And it's almost like, even if you have like one night of brutal sleep, like, yeah, maybe that's one night, but it's not like you can make up for that deficit the next night. That's something that is going to compound on top of every other fuck up you've had in the past however many years and lead to more scratches on the disc, which is going to be pro-aging at the end of the day. So basically, the proposal is that even with all of this happening, though, there is a way to retrieve that, like, OG, like, immaculate information, and then, like, I guess, revamp the body to be able to regenerate that, suboptimally functioning tissue because of that epigenetic noise, and sort of, like, clean up the mess, so to speak, through, I don't even remember how he said he was doing it. It was like through like a virus or something like that. He was going to like have some sort of signaling. I'd have to rewatch the Rogan podcast. But anyways, this is like really out of my wheelhouse, by the way. It's just very, very much interests me, so I follow it closely. So obviously I'm sort of just regurgitating what I am reading, as well as trying to remember what was said on the Rogan podcast. I believe it was like a year ago at this point. So, but anyways, this is really exciting shit, because this is what he was talking about on Rogan as like something that may be a possibility in the future, and is something they're looking into. And now this paper has come out, published on it, basically describing how reprogramming to recover youthful epigenetic information restore vision, and literally proposing the exact thing he was talking about. And when you scroll down to the discussion at the end of the article, it says, here we show that it is possible to safely reverse the age of a complex tissue and restore its biological function in vivo. Using the eye as a model system, we present evidence that the ectopic expression of OSK transcription factor safely induces in vivo epigenetic restoration of aged central nervous system neurons without causing a loss of cell identity or pluripotency. Instead, OSK promotes a youthful epigenetic signature and gene expression pattern that causes the neurons to function as though they were young again. The requirement for active demethylation in this process supports the idea that changes in DNA methylation patterns are involved in the aging process and its functional reversal. However, we do not wish to imply that DNA methylation is the only epigenetic mark involved in this process. It is likely to involve other transcription factors and epigenetic modifications such as the PRC2 complex and H3K27Me3, both of which are involved in maintaining stem cell plasticity and are associated with DNA methylation clock sites. And if you haven't seen the, the Horvath clock, I believe it's called, and it's basically like based on methylation, they're able to like literally tell you how old your biological age is, essentially, like without even knowing it. They can tell you what your body is aged to based on your lifestyle and basically your genetics and everything. So even though you might have a chronological age of 30, your biological age might be like 40 if you have like a really shitty lifestyle and you've like induced all this stress on your body. And the Horvath clock supposedly like pretty damn accurately tells you like where you're at and also can predict like when you're gonna die or something like that. Let me double check that actually, because that's actually a pretty fucking important thing to, maybe it wasn't predict death, but it was definitely an epigenetic clock, biochemical test that can be used to measure age. The test is based on DNA methylation levels. Let's see, Horvath clock predict. The results reveal that the clock can be used to predict mortality. Aging 8 or more years faster than your calendar age equates to twice the typical risk of dying, while aging 7 years or slower is associated with half the risk, Horvath says. Okay, yeah, so it's also used to predict mortality as well. It's not just to predict your actual, like, you know, biological age. So it's kind of depressing sounding, but it's also very interesting at the same time. So anyway, circling back to DNA methylation clock sites, that's sort of what that encompasses. Perhaps the most interesting question raised by these data is how cells encode and store youthful epigenetic information. So like even when you're older, supposedly your cells still retain the youthful information it would need to kind of like tap into and like, you know, restore youthful functions, despite the fact that visually and I don't know, functionality wise at present time, it may be dealing with all of this epigenetic noise that is making you appear and function older. So it's not like you lose the youthful information, which is, you know, previously what you would assume to have happened. You would think that there's no way to retrieve and like turn back the clock. You would think the whatever information or, you know, function would just be like degraded and sort of like incinerated over the years as you age, but it does not seem to be the case. It seems like your cells actually like store it and can somehow be tapped into, which is very fucking interesting. Possibilities for information storage include covalent DNA modifications, DNA binding proteins, RNA guided chromatin, modifying factors, and RNA DNA hybrids that are established early in life. The role of these youth markers would be akin to the observer in information theory, which preserves an original backup copy of information in case it is lost or obscured by noise. We suggest that epigenetic reprogramming, either by gene therapy or other means, could promote tissue repair and the reversal of age-related decline in humans. So, yeah, so basically there's like a backup in your cells, almost like a hard drive, like an additional, like an external drive or some shit that can be like, if something crashes, like your computer gets super old and stops working properly and all of a sudden you lose all your data, then you can tap into this this old backup and restore everything, supposedly. And that is sort of what the data reinforces that they're finding by restoring vision in these old mice that otherwise have like really very poor vision, which is, you know, obviously interesting despite it being a rodent model. So obviously there's, you know, a difference between rodent models and humans. Like we, you know, especially in the my channel, we know that more than anyone in terms of the crossover of, you know, Hirschberger assays and fucking, you know, anabolic activity relative to androgenic activity in the body and how it has crossover between, or lack of crossover in many contexts between mice and humans and blah, blah, blah. But still, like, you gotta start somewhere, and this shit is incredibly intriguing. Like, it's just like baffling, and it, you know, makes me almost wish that like you almost wish there was like more time where you're like in a state that you could make good use of this information, because it's like how many years before this gets perfected to a point that it could actually be like implemented in humans, and by the time that happens, are we all going to be falling apart and like unable to take advantage of it in some capacity? Or is it going to be, how soon is it? Like when the fuck is this shit coming? Like, is this going to be something we can all take advantage of? Is it going to be something that's even available to the general public? Is it going to be just something available to people with whatever, cognitive decline, functional loss in certain tissues in the body, stuff like that? I imagine that would be the first clinical application. For example, like in vision loss would obviously make the most sense. But I mean, like, it almost makes me wonder if some of these like research chemical websites are somehow going to tap into this shit, because there's always, the research chem companies that are trying to like get on top of some of this stuff first. And you never know. Like, it'd be very interesting to see if some of those companies start like really going after, really digging deep into the research on this stuff and starting to repurpose it for research purposes only, and see if there's some way it can be brought to market in a human capacity, and if people are going to start experimenting with it. So I don't know. I don't even know what that would involve, but the stuff coming out nowadays in the past few years is mind-blowing shit, and I'm keeping a close eye on it. And it's not like something I have a significant amount of expertise on whatsoever, but it's very, very interesting to me, and it is something I would want to learn more about, and that's why I stay on top of it. And obviously it's very applicable to your life probably down the line, because this is going to be a very heavily focused on topic. Like, I forget what the saying is. It's like when you're young, you I don't know, you like work for money, or you like spend time to make money, and then when you're older you spend money to get back time, or something like that. And it's like, I feel like this, the statement couldn't be truer. It's like like grinding in your youth to make a shit ton of money, and then when you're older it's like, how do I spend that money just to like look younger and like restore youthful function of organs and tissues and shit? And it's just interesting how this like vicious circle occurs in life, where you're just like, you're almost like netting the same outcome by, like, maybe not, but I mean, like, you're chasing something that you don't have, and then you have this other thing, and then once you get the thing you're chasing, now all of a sudden you're trying to get back the thing that you just lost, that you had before. It's just, it's an interesting dynamic, and this shit is very, very interesting to me. So I'm going to stay on top of David Sinclair's stuff and keep following it, because it's honestly insane. Like, this is the kind of stuff you would see in like science fiction movies back in the day. So anyways, let me know what you guys think. If you guys follow any of this stuff, any of your comments, or anything, like maybe there's other information out there that is worth digging into, other notable publications in the past couple of months that may have been overlooked by me or something like that. Any and all comments help the algorithm, and they're much appreciated by people who are trying to learn and educate each other in this community about stuff we're similarly interested in. So like, subscribe, check out my blog, moreplatesmoredates.com. Follow me on Instagram at moreplates_moredates, Facebook, Snapchat, BitChute, Twitter, TikTok, Apple Podcasts. If you want to support the channel, you can check out anything I'm associated with in the video description below. My TRT clinic, Gorilla Mind, nootropic formulas, Gorilla Mode, pre-workout formulas. I design myself from scratch. My recommended blood test panels. If you want to subscribe to the newsletter, I recommend you do that too. If you want to get updates into my deep dives into bodybuilding pharmacology and endocrinology, you will not get sent those updates if you don't sign up for that. And I also publish private sales sometimes to stuff for like Gorilla Mind, certain things I'm associated with for More Plates, More Dates occasionally here and there. So basically you get the first word of anything if you're on that list. So a lot of incentive to sign up for that. So check that out, and anything else I'm associated with, video description below. Thank you guys for watching. Talk to you soon.